Everybody, very welcome to this webinar. Thank you, In Vitro partners in Australia, to make it happen. Thank you, Sarah, for your engagement. Let's just give an overview about the VICI-Valco companies. VICI-Valco, since 50 years, a supplier for components in the analytical industry, just acquired 3 years ago a gas generator company made Switzerland and in Italy. This company is now fully integrated, and we are happy to present the gas generator product line worldwide. VICI companies, we are in total 600 people, having different sites of manufacturing plants. You have contact with me now in Switzerland. This is the company. About 130 people are working in these manufacturing plants, and just maybe 100 people are in manufacturing. So VICI-Valco is a company with a lot of skill for these analytical industries. We have companies also in the United States, Houston, Paulsbo, and also the company in Baton Rouge called VICI Precision Sampling. The company VICI DBS, acquired 3 years ago, as I mentioned before, is located near to Venice in Italy. And this company is manufacturing all the gas generators, hydrogen, nitrogen, and zero-air, as well as other components like Peltier cooling systems and customized products. So don't wonder sometimes you buy Thermo, or you buy Agilent, or you buy Shimatsu products, and not knowing that inside is a lot of VICI DBS. The VICI DBS Global Sales Organization, we have a couple of people covering the world, from China to the United States. And also you see Srinivas Kara, that's our partner in the Indian territories. And Srinivas, also welcome joining this meeting. Gas generator products. Starting 25 years ago, and we built the first laboratory hydrogen generator to replace hydrogen cylinders. This product became a quite success story until today. About 20,000 of those hydrogen generators are installed worldwide. We have different formats in hydrogen generators. As you can see, a laptop, and also we have a system called Station where you can put the GC on top of the generator, a space-saving system. We do have also a very slim and taller tower version, because space is an issue. Laboratories, they have a battle of, finding a good space for all those equipments. And we also do have systems for industrial application. Many of our users are like Thermo, like Shimatsu, like Agilent, like PerkinElmer. However, gas generators are not only related to applications like chromatography. That's about 80%. The other 20% are more industrial and process oriented. So you can see actually a 19-inch rack system monitoring example, environmental or process application, and the gas supply is supported by generators instead of cylinders. We do have nitrogen generators, more and more important in the LCMS world. We have systems supporting high purity nitrogen application as well as systems for zero air. So this is an overview, and now do you have maybe questions about the company structure and the product overview? Please go ahead. No questions? Sarah, everything fine?
Yep, everything good.
Okay, so let's go into the details of hydrogen gas generators for laboratory. We use hydrogen in different ways. Certainly, the FID, fuel gas supply, is the most important. No FID without having pure hydrogen. This we call detector gas. Additionally, also make-up gas is being used, not hydrogen but nitrogen. And for carrier gas, there are options like hydrogen, helium, or nitrogen. Many people using helium, even they know that hydrogen would be the better carrier gas, but on safety reason, they used to work with helium. These days, helium is becoming shorter and shorter and more expensive. Many reasons, I don't want to go to details, but many reasons will have reasons that helium comes shorter. Okay, these are the cylinders, but what you easily can do, you can replace the helium cylinder, the hydrogen cylinder with hydrogen generator. You can replace the zero air supply with a zero air generators, and that's an easy task. We also have combined generators. So instead of having two separate generators for hydrogen and air, we can give you a combined dual gas generator. In addition, the nitrogen supply as make-up gas can also be substituted by a generator. And last but not least, you can see the hydrogen can be used as a carrier gas to replace the helium or nitrogen supply. That makes a lot of sense, having just an independent solution without cylinders. Remember, the gas requirement for flame ionization detector is hydrogen, is air to create a flame, make-up gas to dilute the sample to control the height of the signal. 90% of all GCs are equipped with an FID, maybe an FID next to another detector, but FID is the most installed detector worldwide. And make-up gas requirement, typically people using high purity nitrogen. However, flow rates for make-up gas is little, as 30 to 50, maximum 100 cc per minute. So That's why we have designed nitrogen generators in the right range of flow rate so that one generator is able to supply multiple GCs. We will come back to the models a little later. However, one generator feed one GC. That's true, but also easy. One generator can supply 2, 3, even multiple GCs. As you can see, we have different flow rates in hydrogen, up to 1.35 liters per minute. This hydrogen production would be good to supply up to 20 GCs. We have two different versions of hydrogen generator. One version is the detector gas generator, producing the right purity of gas to maintain the flame as a fuel gas generator. As hydrogen is mixed with air in the ratio 1:5, 1:7, the hydrogen can have a little bit of oxygen, can have a little bit of moisture inside, because the mixture with air to make a flame is, as said, a ratio 1:7. We have a version called carrier gas, or in the shortage, an NM version. This type of hydrogen is very high pure, not only concerning the hydrocarbons, but also concerning oxygen and moisture. For carrier gas, you cannot allow to have any oxygen or moisture, as this would harm the stationary phase in the column. So therefore, the two versions, one called the PG, the other versions NM, differentiate in the purity of residual oxygen and moisture. Again, NM, very high pure by 6.0. That means 99.9999 and better. The PG version is the 99.999 purity, perfect to feed a flame. Definitely you can use also the NM hydrogen to feed a flame. Once you decide to go with NM, use this gas for both, for flame, fuel gas, and for carrier gas. You see the models. These models are made to your comfort. If using 1 GC, you don't need 1,000 of milliliter hydrogen per minute. So you are good with 100. The size of the generator in the physical size is the same, but inside there are different electrolyzer cells. So the capacity, how much hydrogen can be produced, is given by the different electrolyzer cells. Again, this is the NM series with the purity perfect for carrier gas and fuel gas. The PG versions, called detector gas versions, we also have different models from 100 to 600 cc per minute. 600 cc is good enough to feed up to 5-7 GCs. Remember, an FID consumes approximately 50 cc per minute of hydrogen. The dual gas generators give both hydrogen and zero air in one machine. You can see a picture from a FID station. The station is a space-saving unit. You don't need additional space because you just put the GC on top of the FID station. And for service, you see also on the photo on the right side, you can pull out the whole hydrogen generator, so you don't need to move the GC away from that. Certainly not only thermal, but the Dani, the Shimatsu, the Agilents, and the Perkin-Elmers can be put on top of the FID station. Again, the two different versions, the NM version means good for flame gas and carrier gas, or the PG version are available with zero air supply. The zero air is your laboratory instrument air passing through a catalyst oven in the FID station and getting zero air out of it. Yes, we know that GCMS also has a requirement for additional space because you have to place the mass spectrometer somewhere. Look at this. The extension for the mass spec place is also coming as an option from VICI DBS. The FID station can also be used as a mobile space-saving version. You see a mobile laboratory with a GC where analysts running around and measuring in the field. This is a very common application, not only for environmental analysis or different processes, but also the government is using more and more mobile laboratories for multiple application. So this application you see here is made for diesel control. Now, another format, we do have the FID tower. Whatever you have in the FID station is now packed in a small and slim format to place next to the GC. Also, in mind, not having a lot of space. Again, the FID tower version is available as a NM, means very high pure gas for carrier and for FID, as well as a PG version for fuel gas supply only. That's an image, an FID tower next to an Agilent. On the right side, an FID tower, hydrogen zero air. On the left side, a nitrogen supplying makeup gas. The latest innovation from Agilent, also next, an FID station. No, sorry, an FID tower That was just shown in Japan recently. The next format are rackables, same as single gas or dual gas. 19-inch rack is a standard in process analysis. So you can have the hydrogen and zero air again as a NM type or a PG type. You can have it as a hydrogen gas generator only, or you can have it as a dual gas hydrogen and zero air generator. Following the same strategy of PG and NM, and also following the same flow rates for PG and NM. As an example, you see an FID dual measurements of hydrocarbons supplied with the computer, supplied with power supply, supplied with a manual calibration gas switching system, and underneath the hydrogen zero air generator, and one step down it is the water reservoir to supply the required water to produce hydrogen. Any question as far?
All good.
So let's go a step further. Cascading. This is an exclusivity from VICI, that a simple question. You have a single generator supplying hydrogen for the lab, and on technical reason, this generator needs a service. Means you are down, you have no hydrogen. To overcome, like you do today, you do never have only one hydrogen cylinder. If you have one in operation and one next as a backup, and maybe another one or two just in standby. So we do the same. We just take two or more generators and put them together as a cascading. How that works? The laboratory requires 1,400, and you can see 4 generators supplying the gas. One generator is down, the other 3 still working, and the whole lab will not be down. You can continuously working, even one of the generator requires a service. This master-slave configuration is unique because one machine down, the other 3 automatically understand we need to increase the capacity because one of the partner is down. When master goes down, the system automatically decides a new master, and it will run smoothly without interruption, even when master is away. So that is an automated backup system and welcome in many laboratories. Hundreds of installations are done in cascading. The same also for 19-inch rack application, and even more convenient, the different models, the laptop, but also the stations, the towers, they can connect each other and make cascading. Cascading requires nothing else than an I/O board and a cable. The software is already implemented in each single unit. Once this connection is done, the system can work as a master-slave configuration. So, finally, we also offering remote software where you can control the generator or the cascading family of generators by your computer. So Lab Manager can see at any time the condition of the generators in the lab. A simple Windows shows you all the actual parameters. So, saying this, the generators today are a real alternative to the cylinders. Questions?
So if you have any questions, you can type it in the conversation box on your left, and Heinz will have a look.
Okay, let's go fast to the zero air generators. Zero air, the meaning is no hydrocarbons in air, because you know hydrocarbons is the biggest signal producer on an FID. So not having a baseline with a lot of hydrocarbons, you better use zero air. VICI offers zero air and ultra zero air. Again, zero air, hydrocarbon free air. Ultra zero air, almost synthetic air, means all other impurities, not only hydrocarbons, but carbon dioxide, carbon monoxide, moisture, the NOx, SO2, O3, particles, etc. is being removed. So these two generators are available in different flow rates. Very simple. Use your instrument air, use your laboratory compressed air, passing to zero air and having an excellent signal, low signal baseline. The lab versions can stand on the lab table or you can hang it on the wall. The 19-inch rack you also can use then for rackable application. The compressed air is just passing a catalyst oven, heated up at 600 degrees Celsius to destroy all organic components. You see a signal on a FID with and without zero air. Ultra zero air, remember, removes hydrocarbon, yes, but also removes carbon dioxide, carbon monoxide, moisture, and all other NOx, SO2, ozone components. So ultra-zero air can be used for TOC application, total organic carbon, can be used for many other applications where residuals are not welcome. Replace your synthetic air with ultra-zero air. To remove all those residuals, you see the system includes an PSA system, an NOx SO2 trap, as well as a catalyst oven. The purity from the outlet on GT, on ultra-zero air, is quite impressive. No hydrocarbons, no SO2, no NOx, and very, very few carbon dioxide. The carbon dioxide depends on the hydrocarbons inlet. Maximum 5 ppm. So these are installations to supply laboratory buildings. Any question about zero air? Let's go to nitrogen. Instead of using liquid nitrogen dewar vessels with all the inconvenience and costs, we can also provide you generators using compressed air as a basic material to give you high purity nitrogen in different flow rates. Two technologies helping us to give you this nitrogen out of atmospheric air. PSA technology can produce high purity nitrogen, as you can see, 99.999. That's what you can get out of cylinders. We use compressed air passing through molecular sieve to remove impurities, mainly the oxygen components, the CO2 components, the moisture, to remain with 99.999% of nitrogen. Simple equipment, once installed, works for 3 years without additional maintenance, unless the filtration of your compressed air has to be carefully monitored. We don't want to have too much particles in the system. So therefore, at the inlet, there are inlet filters, and you are demanded every 6 months to change these filters. That's the only consumable we have. The detail of the PSA technology can also be shown and on these schematics, and you can also see that on our homepage. Whisper technology is a membrane, not PSA, but membrane technology. Membranes can separate oxygen out of air, but the purity is limited up to 98–99%. However, so many applications in labs are sufficient purity with 99%. Blankaging, evaporization of solvents, and. So therefore, membrane technology is also an easy and safe technology for many applications. We promote the whisper technology especially for LCMS. LCMS application requires a lot of nitrogen, making a membrane pipe. Compressed air is passing through the hollow fibers. Oxygen penetrates fast out of these hollow fibers, and the remaining gas is nitrogen. As mentioned, the purity in the membrane technology is maximized by 99%. Good enough for many applications. Not so for chromatography makeup gas. There you have to have the PSA technology. So, questions about nitrogen?
There are some questions in the conversation panel for you, Heinz.
Many different applications on side of LCMS can be supplied with gases out from membrane technology like ELSD, also TOC, total organic carbon. And therefore we have different models like Whisper series, small one called mini Whisper, or standard Whisper 0 to 40 liter per minute, supplying nitrogen for one LCMS system, maybe two. Whisper 0 to 80 liter, 2 to 3, and Whisper 0 to 120 liter, multiple LCMS system in the lab. You also can use the generator and fill buffer vessels, and from the buffer vessels then supplying the gas into different labs in the same building or in different floors in the same building. We design the right system for you. Let us know what is your setup in LCMS. Membrane technology requires compressed air, and we count on the compressed air source from your factory, or if needed we can also make proposals which kind of compressor can be the right size and the right choice for feeding compressed air into membrane technology nitrogen generators. The air inlet approximately 9 bar pressure to get 8 bar pressure out into the buffer vessel or directly to your application. You see a Whisper installed in an LCMS lab and supplying directly nitrogen into the MS. Another one here installed just recently in US, by the way. Questions about nitrogen, Whisper technology, that means membrane type of nitrogen generators. Just one model more. When compressed air is not available, when you don't have any source of compressed air, we also offer a type of nitrogen generator independent from compressed air source, a kind of standalone system. The name of these versions are Mistral. Mistral are in standalone units with inbuilt air compressors. This unit, you just connect with power. It starts to produce nitrogen, and 10 minutes after initial startup, you have the right flow and the right pressure to supply LCMS with nitrogen. Outlet pressure up to 8 bar and flow rates up to 40 liter per minute. This product line is very welcome on all the places where there is no compressed air or not sufficient compressed air available. Maintenance-wise, very similar. They are filters to remove particles, and there are some filters to remove the dust. That's it. Servicing those filters in a frequent way, maybe every 3 to 6 months. That's all you need. Please ask your local specialist, and you will see that we can help you. Whatever kind of brand of LCMS you are driving, we know how much nitrogen is required to fit together. Our LCMS nitrogen generator has a regular working hours of 24,000 hours. That is approximately 3 years. After 3 years, the compressors are down, and we recommend then to change the compressors. So that's everything for the minute, and I would like to ask you now, please come on with your questions. I'm happy to have you guys here in the room. Also, Srinivas, thank you for joining.
Thank you, sir.
And Sarah, let me know if there is additional questions. If not, so then we can just finalize this meeting.
Yep. Thank you, Heinz, for covering all the information about gas generators, and we can end the webinar now. And if there are any questions from anyone else, then I will send it through to you.
Okay. Thank you, Peter.
Thanks, Heinz.
Thanks, Sarah.
Thank you. Bye.
Bye-bye.